quadratic equations and what's known as the discriminant. So let's go back to graphing real fast. We learned that there are three different types of solutions for a quadratic equation. So we're going to go ahead and draw out our three possible graphs that we have. We can have a graph in which there's no x-intercept, meaning it never touches our x-axis. We could have a graph in which there's one x-intercept, meaning it touches our x-axis once. Or we could have a graph where we have two x-intercepts, meaning it touches our graph 2 times here. So just one point to reiterate is our graphs will not always look like this, because remember, we're only showing opening upwards, but it could also open downwards. You could also not be right in the smack of the middle of the axis. You could be to the left or to the right. So just keep those in mind, that those are a general vision of what our graphs look like. Now, in thinking about our three different possibilities here, wouldn't it be nice if we were given a quadratic equation, we were able to know the type of graph we would have before we even graphed it? In other words, what if we were to know how many solutions there are to the quadratic equation right from the beginning? So think about it. I'm given a quadratic equation in standard form, and by looking at the equation, what I want to know, well, before I even graph it, what's it going to look like? Am I going to be hitting the x-axis? Am I going to be hitting it once, twice, or not at all? So there's a way that we can do this and figure out how many roots there are, and that is by using the discriminant. So what the discriminant is, it's the formula b squared minus 4ac, where your b, a, and c, they come right from your standard form of the equation. So the discriminant tells us how many roots exist for a quadratic function. It also tells us if the roots are real or if they are imaginary. What's important to note is the discriminant does not tell us what the value is of those roots. It just simply tells us, do we have 0 real roots, 1 real root, or 2 real roots. It does not tell us that, say, for example, x is equal to 5. It does not tell us that. We then have to use a process in order to figure out those roots. So let's go a little bit more into detail by using this flowchart that's created here. So first, after you get your a, b, and c values and you plug it into the discriminant formula, you're going to get a number back. You're going to look at that number. Is that number negative? Is that number 0? Or is that number positive? If that number is negative, you are going to have two complex, in other words, two imaginary or two non-real roots. And what that means is when you go to graph it, it is never going to touch the x-axis, which should make sense because our number line only encompasses our real numbers. So it's never going to touch that x-axis. If you get back 0, so you literally put in your equation and it's equal to 0 at the end, there's only going to be one real root. So that's going to look something like this. You're touching the axis once. If you get back a positive number, you are going to have two real roots, so it touches your x-axis 2 times. Now there's something a little bit more that you have to be careful about. When you get your value, you have to look at that number and say, is this number a perfect square? If this number is a perfect square, say like 4, 16, or 9, you know that your two roots are going to be rational numbers, meaning they are either integers or they can be written as a fraction. If you look at your value and it's not a perfect square, so say like 7 or 2, you know that your two roots are going to be irrational. So they're most likely going to be including some type of square root, and that's going to get a little messy when we go ahead and graph it. So let's go ahead and try our first example. If I have 3x squared plus 5x plus 1 equals 0, I first start by A, making sure that my whole equation is in standard form. When I'm in standard form, that means everything is to the left side and the only thing on the right side is a 0. So let's start breaking down each value. My A term is 3, my B is 5, and my C is 1. So now I'm going to go ahead and I'm going to plug it into my discriminant formula. So I start here. B squared, so 5 squared, minus 4 times my A term, 3 times 1. So 5 squared is 25, and then 4 times 3 times 1 is a 12, and I'm subtracting it. So 25 minus 12 is 13. So my discriminant value is 13. So now let's go to that chart and figure out where it belongs. So first up, I ask myself, is this value negative, 0, or positive? Well, it's a positive value, which means automatically I'm going to have two real roots. But remember, because we are in the positive category, we have to go a little bit deeper. Is 13 a perfect square or is 13 a non-perfect square? So you should automatically be saying, oh, 13 is not a perfect square, which means that my roots are going to be irrational. And that's all you have to do with the discriminant. Here's another equation. Say I have x squared minus 4x equals negative 13. So if you notice, this negative 13, it's got to go bye-bye. So we're going to add this 13 to the other side to make sure that we're in standard form. Now I'm going to go ahead and label again. A is 1, B is negative 4, and C is 13. So now I'm going to be plugging these in to my discriminant formula. So my B term, negative 4 squared, minus 4 times my A is 1 times my C is 13. So I now have negative 4 squared, which is 16. And 4 times 3 is 52. I'm subtracting it. 16 minus 52 is a negative 36. So the value of my discriminant is negative 36. So now let's go back to that chart. Okay, is negative 36 negative, 0, or positive? Well, it's a negative number, so that means I have two complex or two imaginary roots. So when I go to graph it, I am never going to be hitting my x-axis. Okay, here's another example. Say I have x squared minus 6x equals negative 9. Again, this is not in standard form, so I got to move that sucker over there. So now I have 1x squared minus 6x plus 9 equals 0. My A term is 1, my B term is negative 6, and my C term is 9. So now I have negative 6 squared minus 4 times 1 times 9. So negative 6 squared is a positive 36. 4 and 9 is 36, and I'm subtracting it. So 36 minus 36, I literally get 0. So the value of my discriminant here is 0, meaning I only have one root. So these are the different possibilities that you can get for the discriminant. Again, you'll either get a negative, a 0, or a positive. Our discriminant tells us the type and the nature of our roots as we go forward in solving our quadratic functions.